Hey mathematicians, this week we are going to be talking about lines and angles and how lines and angles interact with each other. So in order to have a line, the very first thing that we need to know is that a line is two-dimensional. So it means it goes, it's one-dimensional. So that means it goes one way. Think of like length and width are things with two dimensions, like a square. One dimension would be a line. Now, we start thinking of that with just a point. So a point is just any point on a line, or maybe the start of a line segment or the end of a line segment, and it all kind of starts with a point, and then we can create lines and line segments and things like that. So the first type of line that I want to talk to you about is what we call a line. Now, you may think you know what a line is. Okay, you can draw a line, but there are some aspects about lines that we need to know. So a line is special because a line continues on forever in both directions. So I have drawn here a line. It has an arrow on one end showing that it's going to go on forever and ever and ever and ever in the to the right, and then it's going to go on forever and ever and ever and ever on the left. So if we have something with arrows on both ends, a line that's going to continue forever in both directions, that's what we call a line. Now, it could be a line that goes diagonally, a line that goes up and down. It doesn't matter which way what angle our line is at, because if it goes forever on in both directions, that's what we call a line. Now, when you're drawing a line, you aren't actually drawing a line because it's not going on forever and ever and ever. You are drawing something else, and I will get to that in a minute. Now, we also have something else called a line, or a ray, okay? So a ray looks like this. Oops, not like that. Let me change that. All right, so the next thing we have a line, and then we have a ray. Okay, rays are a little bit different because rays start with a point, and then they go on forever in one direction. So this point here, this dot, is where our ray starts. So that's the beginning of our ray, and then it's going to go on forever. So this one would go on forever that way, this short one would go on forever this way, this one would go on forever that way, and so on. So those rays are going to go on forever in just one direction. So that's what makes a ray and a line different. Now, a line and a ray, a line goes on forever in both directions, a ray goes on forever in one direction. The last thing I want to talk about is a line segment. A line segment is just any part of an already existing line or ray. So a line segment looks like this, or maybe this, or maybe this. So a line segment is part of a line. So if I'm looking at this line here, let me draw. If I'm looking at this line right here, a line segment might be from this point to this point. So it's just a part of a line. So it doesn't go on forever in both directions. It just goes from one point all the way to the next. And next week we're going to talk about how we refer to line segments and how we refer to rays and lines and such. But for right now, there are three types of lines. Lines, which go on forever in both directions. Rays, they go on forever in one direction. And line segments, they have a start point and an end point, and they don't go on forever. They are just a specific part of a line. Now, lines can intersect each other, meaning that lines might run into each other, like these two lines. Oh no. Well, there's names for all the different ways that lines intersect. And you may have heard of these before. When you have two lines that run into each other or overlap or will overlap, like for example, these two lines, they're not overlapping, but this is a line, so it's going to go on forever. So it's going to eventually run into this line. So we could call those intersecting too. So this first type of line where two lines run into each other, we call those intersecting lines. Okay. So we refer to those as intersecting lines. They intersect at a point. So at one point they will touch. So these are all line segments because they don't go on forever. I just use them because it's just kind of what I drew. So line segments or lines that run into each other or touch are intersecting. They run into each other. We also have lines that intersect at a certain angle. So these two lines here, they intersect perfectly at this angle we call 90 degrees. So we call this angle 90 degrees, and since these two line segments run into each other at 90 degrees, we would call that perpendicular lines. So we would call them perpendicular lines. Perpendicular lines or line segments are lines or line segments that intersect perfectly at 90 degrees. So they make this nice little square, kind of this perfect corner there. So that's a perpendicular line. And then the last type of line pair that we have is lines that will never, ever, ever, ever intersect. Even if they continued on forever and ever and ever, these two lines would never touch each other. They're never going to get closer or farther away. That's what we call parallel lines. So we call parallel lines a pair of lines that will never ever run into each other. Okay, so our three types of line pairs are intersecting. They run into each other or they touch at a certain point. Perpendicular lines, they intersect at a 90-degree angle. And then parallel lines will never touch. Now, anytime we have two, you may have seen angles or talked about angles before, but anytime we have two rays or lines that intersect, they create an angle. And we have three main types of angles here. So we're going to talk about more this year, but for right now, we're just going to talk about the big three. This first one looks like these perpendicular lines, this section of it. So this first one is what we call a right angle. So it is exactly 90 degrees. So a right angle is exactly 90 degrees. So this would be a right angle. This next one is a bigger angle than 90 degrees. So it's bigger than a right angle. So we call this angle there's a name for an angle that is bigger than 90 degrees, and we call that an obtuse angle. So an obtuse angle is 91, or sorry, it is, gotta find the symbol, greater than 90 degrees, but less than 180 degrees. Okay, so that's an obtuse angle. So anything greater than 90 degrees but less than 180 degrees. 180 degrees would look just like a straight line. And this last one is less than 90 degrees, and we call this acute. And that is less than 90 degrees. So an angle that's smaller than a right angle, an obtuse angle is bigger than a right angle, and a right angle is exactly 90 degrees. So as you're working today, you're going to notice that you're going to be creating some shapes where you might have some angles, some types of lines, and so on. So you're going to look at some shapes and say, okay, you might be tasked with creating a shape that has a right angle. Well, this square, I notice, has a right angle. So this would fit that it has a right angle. It also, since it has a right angle, has a set of perpendicular lines because these two lines right here meet at a 90-degree angle. It also has a set of parallel lines. This line on top and bottom will never touch each other, and then these lines on the sides will never touch each other either. So they would not only have parallel lines, they would also have perpendicular lines too. This triangle, on the other hand, it has an angle that looks less than 90 degrees. So if I were to draw this line up to make it 90, oops, wrong thing. There we go. So a 90-degree angle would be about here. So this is less than 90. So that would be an acute angle. And here we have an angle that looks about 90 degrees. So we would call this a right angle. Now if I were to change this shape, if it'll let me, now I don't have a right angle, I have an obtuse angle. So an angle greater than 90 degrees. So you're going to be looking for these types of angles, these types of lines, and line segments and rays today and this week in Hot Topics. So we are going to build on this next week and talk more about lines and rays and angles.